fourth question taken from textbook Self-Practice 2.13, question 5. Right, so we have Chandran which walks away from the lamppost, which is this one, at a rate of 3.5 meters per second. So let's say Chandran is here, and after 1 second he will move 3.5 meters to the right, and let's say he is somewhere here later. Right? So for this question, right, let's use an unknown to represent the distance from the lamppost to Chandran. Okay, so let's put it as y. Then we are given the heights of Chandran and the lamppost, which is here. Then we need to find the rate of change of Chandran's shadow. Okay, so for this shadow, let us also use an unknown to represent this length, the shadow length. Okay, let's put x. So how do we find the rate of change of Chandran's shadow? Okay, so we can use the 2SF method that I explained, mentioned in the previous videos, right? So the first step, or the first S, is search. Okay, so the rate of change that we want to find would be dx over dt, right? Because x is a shadow, and dt because we need to find the rate of change. Okay, second step, or the second S, which is split. So we need to split this fraction into 2. So numerator, I put it in the first fraction, denominator, I put it in the second fraction. Third step, or the first F, is fill in the blanks. Okay, fill in the blanks here. So we need to find another quantity which is similar to x. Okay, so here the only quantity that we have is y, right? The distance from the lamppost to Chandran. Right, so let's put dy in these blank spaces. Okay. Then the last step is to find. So what we need to find is the values of these two quantities. Okay, so for the first quantity, this one, we need to have an equation. Then we can only differentiate to find this. Okay, but here the problem is we don't have an equation. Right, so how do we find this equation? Well, we can use this picture to help us, because you can see, right, here there's a big triangle, and then if you look at Chandran, so you imagine Chandran is a line, right? There is also a triangle inside the big triangle. Okay, something like this. Okay, and this is the measurements. So if we have a triangle which is inside another big triangle, we can use the ratio method to help us form an equation. Okay, so now let's compare the base first. The small triangle's base is x, right? And the big triangle's base is x plus y, right? Okay, so let's put it here. Then we compare the heights. So the small triangle height is 1.8. The big triangle height is 6. So if you look at here, right, if I use x divided by 1.8, the base divided by the height, and x plus y, the base of the big triangle, divided by the height of the big triangle, technically these two values, if I divide, it will have the same value. Reason is because this triangle is inside the big triangle. Technically their ratios will be the same. So we can form the equation in this way. Right? So now, once we have this equation, I will put x on the left, everything to the right, to form my equation, which is x equals to 3 over 7 y. So now I can use this equation to differentiate to find dx over dy. So now y is subject, so you can see that y, the power is 1. So if I differentiate, this will disappear, so we have only left with 3 over 7. Okay, so we have found the first quantity. And the second quantity we need to find is dy over dt, the rate of change of the distance from the lamppost to Chandran. Okay, so what is the change for every second for y? Which we have already known from the question. It says Chandran will walk away from the lamppost at 3.5 meters per second. So it will become longer, longer and longer. So this is actually the rate of change of y. Okay, so this is dy over dt equals to 3.5. So now we have these two quantities and we can just multiply them together to find the answer, which is 1.5 meters per second. Right, so what does this mean? Okay, let's say the shadow just now is, let's say, 0.5 meters. So after 1 second, it will add 1.5, so it will become 2 meters. Alright? Second question will be to find the rate of change of the moving tip of the shadow. Right, so the moving tip is here, if you're wondering. So how do we find this rate of change of this tip? So let's compare two scenarios. Okay, the first scenario is the original scenario, which is this one. The second scenario is what happens after 1 second. Okay, so originally Chandran was here, right? And after 1 second, he goes to the right, so he will be here. So now, if you compare the moving tips, right, before and after will be here and here. And the question wants us to find what is the change of this tip. What is the, I would say, the distance that the tip traveled for every second? Because he travels from here, then after 1 second he travels here. So like, what is the, I would say, how many meters does this tip go to the right? We need to find the value. Okay, so there are only two factors that causing this tip to go to the right. The first one is Chandran himself, right? Because for every second he moves to the right, so this causes the tip to go to the right. This is the first factor. The second factor is once Chandran moves to the right, the shadow will increase the height, increase the length, right? Which we already found in part A, which is the shadow will increase 1.5 meters. Okay, which is, let's say it's here lah. Okay, so now if you want to find the quantity where the tip goes from here to here, and this thing is only affected by two factors, 3.5 and 1.5 here. So to find the change, very easy. We just need to add them up. Okay, because technically these two are only factors that are causing the tip to go to the right. So we just add those two together and find our answer. So it's 5 meters per second.